Networking training, switching lab 2, VLAN concepts and configurations. In this episode, we're going to show you basic VLAN configurations and some basic troubleshooting tips like display the VLAN information, display the ports membership of a VLANs, as well as display the MAC address tables of a switch. For a very first simple network, as a computer network involves the connection of two or more computers to enhance resource sharing. So here we have PC5 and PC6 with the IP address of PC5 192.168.1.1 and PC6 192.168.1.2. So let's test communication between PC5 and PC6 here. So before we proceed, I just want to verify the IP address on this by issuing the command ipconfig, and here we can see the IP address is 192.168.1.1, and this is also called the logical address of this computer. All right, so if I want to know that this PC is communicating to the other one, I can use the ping command to test connectivity to the other end, which is 192.168.1.2. Okay, and I press enter and we can see reply. So ping is an ICMP protocol, that's Internet Control Messaging Protocol used to test communication between two nodes on a network. This is a protocol that operates in layer 3 of the OSI layer models. So good. So if you don't know how to use packet tracer and set up this simple topology, please check on our video on 10 tips of packet tracer. Okay, so this is a simple topology, but in a small to medium-sized enterprises, sometimes you will have like 50 to 60 computers connected, and this will not be very scalable to be connecting one computer to another in this peer form. So let's see how we can fix that. So here we have a better setup. Here we have a switch, and our other computers are connected directly to the switch, whereby each PC can communicate to the other going via the switch network. So here we remember that a network has three components. One is the media, that is the cable that is used to transmit data. Two is the devices. The devices are further categorized into two, that's end devices and intermediate devices. We also have services. So here on devices, we have example of end devices are our computers, servers, printers, and the like. An example of intermediate devices is a switch. So this switch is the first intermediate device that our end devices will connect on. So here I have PC1, PC2, PC3, and PC4 plus a file server. So let's test that PC1 can communicate to the other computers. I can ping, or first of all, let me verify the IP address on the PC with the IP config command, and we can see the IP is 1.1, and I can ping the other PC, which is PC2, which is 1.2. That is looking good, it's replying fine. PC3, that also is responding. PC4 is also responding good, and the server, which is .5, which is also responding good. Fine. So this IP address, as I said, is a logical address of the computer. Let us also check the MAC address of this computer, or we call it the physical address of this computer, by adding /all to our ipconfig command, and we press enter. If we scroll a little bit up, we can see that this first external 0 on the computer has an IP address of 192.168.1.1. and it also have a physical address of 001.6390.6619. So this physical address is also called the MAC address of this computer. So how does this switch know that PC1 is trying to reach PC2? Which port I should forward this communication to? So let's see how that works. Okay, so here we have a diagram of a switch, and we have our four computers connected to it, right? So PC1 on FA0/1 and PC2 and 3 and the like. So a switch has what you call a CAM table or a MAC address table. So this CAM is content addressable memory. So it contains the port number of a switch and the MAC address of a device that is attached to that port. So here we can see PC1 is connected to port 0/1. But we don't know the MAC address because the MAC address at the moment is empty if the switch is just newly powered on. So let's say PC1 initiate a communication by trying to hit a PC3 with a ping command. Okay, so PC1 will just send that message through its port FA0/1 and hit the switch, but the switch will not know which port is connected to PC3. the switch will only know that, okay, there is a communication message coming from PC1 which says my IP address is 192.168.1.1 and my MAC address is 11111. So the switch will say, thank you. Since I know that your MAC address is 11111, now I'll fill my account table with your information. So the switch will quickly say, my fast Ethernet 0/1, which is connected to my PC1, has the MAC address of 1111. So that also will be added right away. 1111. Good. So the next PC, the switch is supposed to forward that information to PC3, but the switch doesn't know which interface is connecting to PC3. The switch now send an ARP request in the form of a broadcast and said, I am looking for the PC that have the IP address 192.168.1.3. Okay, and that information will be sent out to all the ports of the switch except the ones that was originated. Okay, that was FA0/1, because this PC ping, use the ping command and say I was trying to hit this 1.3, so the switch now broadcast to everybody. And because PC3 is the one that has the IP address of 1.3, now PC3 will reply and said, I am the PC with the IP address 192.168.1.3, and the switch will say, okay, thank you. Now I can also know that your MAC address is 3.3.33, so I will also label my port FA0/3 has the MAC address of 333. That will also be entered in the MAC columns, 3333. Okay, so now the reply will be forwarded back to PC1 out through this fast Ethernet 0/1. So you can see a simple communication has occurred between PC1 and PC3. Okay, so the switch will continue this thing and fill the rest of the CAM table or the MAC table. So the next time PC1 is communicating to PC3, the switch will go straight to the MAC address table and look for the MAC address that is having 333, and it will find that it's in port 3 and forward it out only to port 3 instead of broadcast to the rest of the switch network. Okay, so this broadcast normally will hit every port that is in the same network as of PC1, or is also called the broadcast domains. So let's say this network was for a company that started operation 2 years ago, and all of these users were in the same department, the admin department. So now a decision came that we have to separate this department into two now. So we want Omar and Farid to be in the same department, and Joe and Smith to be in the new department, in the sales department. So to do that, let's see on the switch configurations. So if you go into the switch configuration command, and then we can display the VLAN informations by issuing the command show VLAN. Here we can see that all of these ports are in the default VLAN 1. So that means all of them will communicate by using the same subnet. All right, so we first of all separate these two ports. Port 2 and port 3 will be put in a new VLAN. So to do that, I'll go and create a new VLAN. Okay, with the command VLAN and the VLAN number, VLAN 2, and I give it a name called sales. All right, sales, and I should make sure that Smith and Joe are in that new VLAN. So I will have to assign port 2 and port 3 in the new VLAN. So I'll go to port 2, interface fastness 0/2, and say switch port mode access, and then switch port access VLAN 2. All right, go to the other interface FA0/3, switch port mode access, okay, switch port access VLAN 2. All right, and I exit. I exit one more time, and if I display the VLAN information again with the command show VLAN, now we can see port 2 and 3 are in VLAN 2 or the sales VLANs. So here, let me go back and test communication. So if I go to PC1, I should be able to ping Omar. I should be able to ping PC4, but I should not be able to ping Joe and Smith, or PC3 and PC2. So let's go to PC2 and try to ping PC4, ping 192.168.1.4. So that one is responding fine, okay? But I should not be able to ping 3 and 2. So let me ping 3. So that one is not working, okay? So I should not also be able to ping 2, simply because they have been moved to a different VLAN. So remember that VLAN equals to a subnet and equals to a broadcast domain. So what do I have to do? Let's test that PC2 and PC3 are communicated. But before we do that properly, we have to change the IP address subnet. So to change the IP address subnet, I have to go there and then give it a new subnet. Let's say this one will give it a subnet of 192.168.2.0/24. So here I'm going to assign it 2.3, and I will change this subnet of this one to be 2.2.2. Okay, so let's effect those changes in the computer. We're going to the IP address configurations, and this one I will now change it to 2. Okay, and go to the other computer and change the IP address from 1.3 to 2.3/24. Good. So here I can come to PC2 and now test communication to PC3 by pinging the IP address of PC3. Ping 192.168.2.3. So you can see a reply is coming. So PC2 can now ping PC3, and PC2 cannot ping also the other people in the admin department, 192.168.1.1, or cannot also ping 1.4. Okay, that's the end of this video. Thanks for watching. Please subscribe now, and I will see you in the next one.